Chapter 3, Lesson 1 of Advanced Algebra, a quick review of graphing these linear equations so we can go ahead and find the intersection point, thus solving the system. Again, you need 2 points to determine a line or to draw a line, so these equations will be given to you in either slope-intercept form or standard form. I'll also review horizontal and vertical lines, what those equations look like very quickly. And then you're going to need to graph those and find the intersection point again to solve the system. Now, notice down here that all equations can be put into slope-intercept form by solving them for y. Now, in this lesson, we're not really concerned with how you graph them. We're just concerned that you actually graph them correctly. So if you're most comfortable with putting them in slope-intercept form, then by all means put them in slope-intercept form and then go ahead and graph the equations because we're looking for the intersection line. If you remember how to graph from standard form, I'll run through that real quickly. I won't do an example. Then go ahead and do that. But again, go ahead and put it in slope-intercept form if that's what you're comfortable with, because we're just interested in getting these graphed and then finding the intersection point where we're not really concerned with how you graph them. You remember that slope-intercept form is y equals mx plus b. The way to graph once it's in this form is to go ahead and put the y-intercept on the graph. That's the b value. Then from that y-intercept, use the slope. Go rise of 1, run of 2, or whatever that is. The only thing to keep in mind, remember, is if the slope is negative, one of the two values, the numerator or the denominator, needs to be negative. Or you need to go in the negative direction. So that can be either down, because that's negative, or left, that's negative. The important thing to remember is you don't make them both negative, because two negatives make a positive. So you're either going to go down negative and right positive, which would give you a negative slope, or you could go up positive and then left negative, again giving you negative slope. Once you have the 2 points, go ahead and connect the points, and then again using a straight edge. Now this is very important that you use a straight edge because we're trying to find the intersection point, and if you're not careful in drawing these, you're going to have a tough time coming up with the exact intersection point if you're not careful to use a straight edge to find out where these intersect. So a quick example, if we wanted to graph these, would be y equals minus 2, let's say this system here, and y equals negative 2x plus 7. So I'm going to do that very quickly for you, and then I'll run through the standard form and then we'll wrap this up. So again, if I'm doing this, I need to put a scale on my axis and label my axes if they're not already labeled. A normal scale of each grid being worth 1 is going to go ahead and work with this, so that's what I'm going to use. So I'm going to graph the first equation, which has a y-intercept of negative 2. So I'll put a point at negative 2. The slope is a 1, so that's a rise of 1 and a run of 1. So I have my second point here, and then I go ahead and use my straight edge again to draw my line. Again, make sure you use a straight edge so you get a nice straight point there. And then I'm going to graph the second equation, which has a y-intercept of 7. That's way up here at the top here. And it has a slope of negative 1, or negative 2, excuse me. So because I'm up here, I'm going to go down 2, which is negative, and then I'm going to go right 1, which is positive, so that negative and then that positive make a negative slope. So I have my 2 points, so then I'm going to go ahead and use my straight edge to graph those. And you'll notice I don't, so then again I'm using this now to solve for the equation, so I'm looking for the intersection point because that point is on both lines, which would make both equations true. So that's right there. And so my intersection point has a coordinate of 3, 1. So if I substituted the x value 3 and the y value 1 into each of these equations, I would get a true statement, which is what I'm looking for. And so that would be the answer to this, or the solution to this system. So you can go ahead and do that if you're doing slope-intercept form. Standard form, remember, is ax plus by is equal to c. And again, you can solve for the x-intercept by putting in 0 for y. Solve for the y-intercept by substituting in 0 for x, and then you have your 2 points, connect with a straight edge, and then go ahead and look where they intersect. Again, if you're not comfortable with that or don't remember how to do that very well, just go ahead and put it in slope-intercept form and you'll be okay. Horizontal and vertical lines, a quick review of their equations. Remember, horizontal lines will always be in the form y equals a number. So here y is equal to 5. You can see all of the y values are 5. So that's what the horizontal equation will look like. A vertical equation has the equation that looks like x equals some value. So again, if we have x equals some value, all of the x values are the same. So that's what the equation would look like. So in a system, if one of your equations is in those forms, you can graph those really quickly by remembering what those values look like. Okay, so that's how you would graph using these. I'm not going to do any examples. I think that's going to go ahead and wrap up this video. We have one more for this lesson, and that is how to classify these systems, and we'll pick that up in the next video.